We're going to have two more iterations of PolyAngle before we're done with that one. This next one is going to be in Java. The problem is exactly the same. Calculations are exactly the same. We are doing something new here. We're using a two-string method. Remember when we did the str, the double underscore dunder str method with Python, where from the class, we create a string that gets returned, and then whatever type of program it is, displays or prints it out. That makes our class independent of our implementation. So our program can be graphical, it can be web, it can be any type of, it could be an Android phone app, whatever. Doesn't matter how it's displayed, we return a string which can be displayed in any type of program. So this gives an example of how to do a two-string. So PolyAngle calculator, we want to create two files. And I've already created them, so I'm going to make them a little bit different. As far as the names go, I moved to a different folder so I can just start from scratch. So we need a PolyAngle calculator, or whatever you want to call it. This is going to be our class that contains all of the logic, all the calculations for our program. And then we're going to have a PolyAngle, we'll just call it main, or you could call it app, whatever you want. That's going to be our main application. This already puts in some stuff for us. One way to go from one version of a program to another is, instead of starting from scratch, find a previous version of it. So here is one of my solutions for the whole perimeter thing. I'm just going to do the whole thing here. So here is my class. It gets and it does all this sort of stuff, and it displays, which I probably need to fix that, but I'm going to grab all this and use this as pseudocode. So let's go over to here. There, have to get behind it. So here's our calculator. I'm going to use this all as pseudocode, so I'm going to select it all and Control/ to make it all pseudocode. Then I'm going to create my class. PolyAngle calculator. There's my class. So as I'm looking through this, I can see that, yes, I have a list of all my PolyAngle names, but let's start with something a little simpler before we worry about that. We could do this by getting, which is what I did in this one, getting and setting. That's one way to do it. Another way to do it is to use your constructor to get that information. So let's do it that way. So we're going to make our public void PolyAngle calculator. And we're going to start out with just one input. We're going to say how many sides, which needs to be an int, and then sides. And I probably have something wrong here, so just a second. So I copied some of the code up here for calculate angles, and I created the constructor. So calculate angles is going to be a public method that's going to return, and that's probably why it's giving us trouble. We need to return a value. But do we need to return a value? Sure. Let's just return the angle. We can return that to the other part, or we can keep it as a method, as just a void method, and instead of returning, we can keep it as a internal, and then do a string to send everything off. All right, so here is my, whoops, that's too many. Sorry. Okay, so we know we don't need that. We're going to calculate. Here's our calculations. We don't have to do the math again. There we go. And we're going to uncomment this and this, and then modify it, because this is fine for a comment. That tells us what we're doing. Now, we need self-interior angle. We need self-exterior angle. Well, things are named differently. There's a different naming convention. So we need private int. What do we need? Interior. And then angle. Notice how they use a camel casing kind of a thing. And then we need a private int exterior angle. There. Now this is going to be this dot interior angle. Except we need it to be the right one. There we go. Now how do we cast something to an int? Because we don't have the number of sides, do we? Well, here is our number of sides. So instead of number of sides, we just say self.sides, -2. Well, that's fine. Can we multiply by 180 in this? Yes. Do we have a self dot? No, we have this dot. We have this dot sides. We have this dot sides, but we want to end up with an integer. So in Java, how do we cast things to an integer? Well, that would mean, let's take a quick Google. Well, a quick Google search came up with how to cast something, and you just put parentheses around it. That will cast this calculation, whatever it happens to be, and it will become an integer. Same with this guy. So there are similarities between the languages. There we go. Now we just need this dot sides. And we store that in our new self-interior angle. Might have been easier just to copy what I needed from the other program rather than mucking this one up. There. So that stores the information in our object variables. We're good there. We don't need any of this. We don't need any of that. We could delete all this stuff. Anyway, we're just going to move this down and finish up our class for now. Now, to make sure that this is working, let's do an override. Let's see. At over. Yep, we're going to override the toString method, which is the same as double underscore str in Python, which I don't have an example of that, but we can put one together pretty quick. Public string. And because we said override, we're going to override the built-in string function. There we go. And now we have a Grubel here. Oh, yeah, it needs to return a result of string. So we need to create a string variable. I will just say string message. MSG is a good name for it. And then at the end, so we don't have the red stuff haunting us, we need to return MSG. Just that's a generic message. And it's probably going to say there's nothing in it. It may not have been initialized. Well, that's fine. Let's initialize it. So we will do MSG equals, and the first thing that we want to do is put in the interior angle. So we'll do interior angle, right? And let's concatenate that with the actual value of the angle, which is going to be this dot, we'll say interior angle dot toString. I'm in the wrong programming language. Yeah, dot toString. And we can format it if we wish, but we're not going to bother. I'm in the wrong programming language. I'm thinking of something else. All right, well, that's close enough. You can look up the string.format and find out how to make it look pretty. I just can't remember exactly how to do that. So we've got our base stuff done. Now we know with our other program, we're going to need to create the object. Oh, we also need our public static void main. So one of the first things we want to do is create our object. And we know at some point we're going to need import. We're going to need to have input from the user, import java.util.scanner, right? So the shape of this program is very similar to other programs. We do need to initialize a new scanner. I'm going to copy and paste some stuff from my solution to this program that I did earlier today. There, now we have our scanner as input. And I'm going to copy and paste some of my solution here, which I realize now I was taking shortcuts, trying to prototype it. So I should declare it the right way around. Int number of sides. There we go. So now we have the int number of sides. We have things coming in as an integer. Do we need anything else to test this out? Let's see. That's it. So the only other thing left is to create usually you create all your objects and declare all your variables up here. And typically you declare all your objects up here. So we need an object to represent our PolyAngle class, right? So I'm going to copy the code I used over here to do that. And that'll go right here. And then anything else would go there. And the only thing we're going to do is create I did it in the wrong place if I'm going to use the constructor, aren't I? There we go. So this should have number of sides. Let's see here. Match that up. Yeah, number of sides, because that's our variable. Number of sides. We're not using the calculator. Sorry, most of the time you create your object up here, but in this case we can't create our object until we get our input if we're using the constructor. Now to print this out is not very hard because we've got everything put together. Let me find that part of the code here. There it is. And, oh, that's a line I don't need because we can do that somewhere else. Oh no, this is a better way to do it. That's right, I remember now. I wanted to have results to let people know what's happening here. So pretty much a skeleton. There's something wrong over here. What doesn't it like? Do we have something that's hanging out? Let's see what it says here. Okay, so there's a statement that's not complete. Oh, yep, there it is. Forgot a semicolon. And we also need a parenthesis because we want to enclose this. Well, we don't have to enclose it. I just like it that way. Now we go ahead and run it and see if we get lucky. Ooh, we put in 3 sides. There's our interior angle of 0. So we know we have something wrong because with 3 sides, the interior angle is not 0. So let's take a look at this. Well, I did a few things. I simplified this because really I didn't need all these parentheses. I didn't need to convert it to an int because it already is an int. When you do division in Java with whole numbers, you end up with a whole number. So I didn't need that. I didn't need the int doing anything here, but that wasn't it. And then I remembered, oh, to calculate the angles, we have to call the method. So we have to call our calculator dot calculate angles. Then the angles get calculated, then we get some results. So we do 3. There, 3 times 60 is 180. That is the correct interior angles for a triangle. And then you keep going from there. So you can kind of see how I used, well, my Python program wasn't quite in this sort of a shape, but I'm going to change it so that it does. But it did have the basic calculations. Some of that I didn't have to figure out again. It's also going to have, when you get to the part of the polygon names, you already have an array here. You can just keep going and picking out code, and it helps you with the shape of it. Notice this is shaped a little bit differently than I've been doing programs lately. I need to change this so it more matches the better division of church and state, meaning MVC, Model View Controller, so that we have all the logic in the class and all the display specific and input in the program, which is what this one's going to end up being, because that's really a better way to do it. All the logic, all the calculations are here. All the input-output is here. That means we can use this with any interface we want, as long as it's Java. Well, I hope that helped.